other questions? Yes.
Yeah, several times you talked about the bandwidth of the brain, but it seems like the description that you give fits long-term memory, different types of long-term memories. It doesn't actually describe what we are conscious of in our short-term or working type of memory. So there seems to be a disconnect between your description of bandwidth of the brain versus what we're actually conscious of.
The brain is an extreme example of what they call processor and memory architecture, which means that the processor, this is what's happening in computing now, like a GPU enables much more processor and memory architecture because basically the high-end GPUs today have 5,000 cores. And they have memory right next to them. You can stream memory into them. It will store like a matrix, and then you can stream data past the matrix to ka-chunk, ka-chunk. Does it match? Does it match? Does it match? Yes, no. And it can do this at a very high rate, and that's why it's being used in artificial intelligence today. But Google, so that thing has roughly 5,000 simple mathematical processors. Google's new chip has 22,000 simple processors. So you're increasingly distributing the processors near the data, and that's called processor memory. And each neuron is a simple processor. So the awareness is happening, there is an awareness happening at each, I mean there's awareness along the whole chain, but the neuron is a sigmoidal activation. It goes from off to on. Yeah, so there's an awareness of that on.
But that type of brute force method might work fine for if you want to have some sort of artificial construct, but it doesn't apply to human consciousness. And if you want your model to apply to human or biological, because human doesn't work that way.
It doesn't work how? Processor and memory, it's got neurons.
It doesn't work in the sense that we have simultaneous conscious awareness of what's going on in all of our neurons. We have a limited capacity of 7 plus 9 is 2.
No, that's true. If you look at activation of the brain, it sort of flutters around between different regions. And no, I would agree with you totally that number one, you have many different degrees of awareness. You tend to only have clear awareness of a very small part of your brain at any given time. But you have a weaker awareness of more. But at any given time, I mean, I think the average neuron fires something like once every 5 seconds. So, I mean, not everything's active at once.
Which would be just random noise in many cases.
Some of that is noise, and noise actually plays a valuable role in the computation of the brain.
But again, if you want to have a system, if you want to have a strong AI system that actually models the way that human consciousness works within the biology that we currently have, you have to match the same limitations that the human processor has. And it doesn't process using a brute process, millions of calculations per second strategy.
Oh yeah, it's much slower, yes. It's massively parallel, so it can afford to be slower. Yes, you have the cortex, the numbers vary from like 16 to 22 billion neurons in the cortex. You have roughly 86 billion neurons in the brain. The cerebellum has the most neurons of any part of your brain. So, yeah, most people don't think you have consciousness of the cerebellum, although the cerebellum plays a key role in timing the stuff you are conscious of.
Well, also timing things you are not conscious of, walking or and things like that. But the point is, though, if you want to explain the biological or organic sort of human consciousness, there are these limitations that need to be attended to. If you just want to potentially describe consciousness in an artificial machine, that's fine. There's no a priori law that says that has to use the same mechanisms that humans do. There could be multiple mechanisms that are creating different consciousness states.
Right.
But if you want to have either a generalized theory or a theory that applies to humans, you have to pay attention to the hardware limitations of humans. And we have, for example, a long-term memory that has several different types of information, but we can't have all of that information in our conscious awareness at one time. We're only limited to roughly 3 bits or 7 plus or 2 minus chunks of conscious awareness at one time.
Right, because conscious awareness tends to mean you have a high percent of the patches in the brain. you are most consciously aware of the things you have the most patches of your brain listening to. So the brain can only have a high degree of awareness of a relatively small number of things. I mean, you know that, what's the magic number 7 thing?
Yeah.
+/-7.
And that may well be related to the fact that 7 is probably the, remember I talked about those repeated sequences of activations? A 5 hertz wave with 8 things per wave cycle would operate at 40 cycle basic system. And the brain can actually go a lot higher than that. And you know, you hear people talking about near-death experiences and all of a sudden everything happens. Well, they had a thing at the toward decided conscious, some guy did some studies on, you know, brain waves of a dying rat, and his brain waves went way up. So he probably had some amazing flashes as he was going. I mean, this poor little rat, they just gave him a heart attack and then, you know, tapped his brain. But you realize dying is a psychedelic experience, or at least it can be.
Well, and the stories that I've researched are after somebody's dead, not while they're dying, but they've been dead 30 minutes, or one guy was already in the morgue and out of his body and experiencing a lot of things in a non-local kind of way. His brain was not functioning.
And if consciousness is a biological phenomenon, like you said earlier in response to this lady's question,
It's
an out-of-body...
our consciousness is a biological phenomenon. It doesn't mean that artificial intelligence consciousness would have to be.
Here's a question that has kind of nagged at me throughout most of this. If our computational awareness, i.e. consciousness, is a product of biological interaction and functioning, I know or I assume that we can shift our awareness or our state of consciousness, which to me implies something that, for lack of a better word, I'd call a will. What's the genesis of this thing we call will?
So you're talking about self-determination or whatever?
Something like that. I don't have a really good way. That's, like I
Right.
said, for lack of a better word, I'll call it that.
Right,
What
so
the
do you
genesis
have free
of that?
will? So my feeling is that depends how you define free will.
Well, I'm not necessarily calling it free will. I'm just calling it a will, a determination of some
Right.
kind.
Right.
It generates from somewhere. From whence does that come? Does it come from interaction? And if that's the case, how does it then turn around and shift the interaction that takes place?
Well, emotions are,
Okay.
I wish I could show you pictures. I have a drawing I call Your Emotions Have Your Brain by the Balls. And basically, you know, it basically shows a lot of the emotional control hardware in the brain, which is like hypothalamus, amygdala, mammillary bodies, the whole pervades circuit. Because remember that thing I said about if your mind is open to any thought, then chances you should do anything that would advance your own chance of living and approach 0 is the limit. That's why emotions have to play a key part in a free-running computer, a computer that has the ability to sort of focus its own attention. You need some mechanism to keep it on track.
Well, every cell in your body has some small degree of consciousness, and your body connects to your conscious awareness through emotional reactions.
Right. You've probably seen the YouTube videos about amoeba. Amoebas actually seem to have some smarts, even though they have no neurons. Have you seen? I mean, Google that. It's kind of interesting. You know, a cell is an absolute, well, you saw that video. That's just only the genetic replication part of the
But
cell.
they're little beings. Each cell is a little being.
Yes, yes.
And they interact hugely, and they all come up here.
Right. At a lower level, each atom is a being. You know, I mean, each particle is a being.
Consider yourself an atom in the body of God, man.
Yes, I mean, to the extent that realityism, that would make sense.
Atoms don't reproduce themselves, but amoebas do.
Atoms can, well, DNA reproduces, it can be
That's the
reproduced by
function.
atoms and molecules. You just saw it.
It's made up of atoms and molecules.
What?
It's made up of them, but
Right, but no, but it actually reproduces, they actually reproduce
I
themselves.
guess that a matter of definition at what point,
You remember that first
is
thing?
there a barrier or a point, in fact?
Well, so many philosophical arguments depend on definition. And, I once, years ago, went out with a woman, who was probably 15 years older than I was. She had a PhD in philosophy, and I'd gotten soured at philosophy, because when I was at Harvard, most of the kids would sit down and examining all the philosophers. They'd say, if a tree falls in the forest, does it make a sound? I said, well, if you depend sound by airwaves, yes. If you depend sound by something somebody's brain recognizes as sound, no. And Schrodinger's cat, Schrodinger's cat, nobody believes in anymore. They believe if you could have a teeny, tiny micro cat, it might be alive.
They don't believe it because they don't understand it.
What?
The Schrodinger's cat.
Well, no, basically people believe a cat would decohere in something like 10 to the 24 negative seconds. 10 to the minus 24 seconds, like a trillionth of a second. So that's really not a meaningful alive dead cat.
They just don't believe in superimposed realities.
No, they believe,
potentials.
because superposition requires coherence, which means, remember I talked the thing about how quantum waveforms, they have these different superimposed states, but they have sort of different harmonic phases. So that in order for superposition to be maintained, there has to be the waveforms have to be orthogonal. They have to not affect each other. And they have to be, everything has to be totally linear. And what happens in a lot of quantum reactions is two things come together and they bang the system so that it is no longer like perfectly harmonic. Instead, you get feedback between the different states and they interact and you get a change. So that's decoherence, and they're basically saying that the more complex a system is, the more things are banging around, the harder it is to maintain a coherence.
And in potential, there are no things, it's all just potential. So,
Well, any of you guys heard of PBS Space Time? It's a YouTube channel.
Schaefer?
And there's this guy called Matthew O'Dowd, who's an Australian guy, and he's actually kind of an interesting guy. He's kind of funny, but he's always against the green screen, so he's floating around among space or molecules or whatever, particles. But he says that the current theory of the standard model of physics is that there are 6 fields. 3 of them are force fields, and the other 3 are particles in that force field. And so you have electrons and electromagnetic stuff. I don't know where a proton sits. You have, and a particle can be in more than one force field, so that you get interactions between fields. And then you have the strong force, which is what holds gluons and a proton together, and quarks are the particles for that field. And then you have gravity, and you have what is it? I forget what the particle is. And then, but then you have the Higgs field, I think.
Graviton.
Yeah, graviton.
Yeah, but you have the Higgs field, and the Higgs field is this bizarre field. The other fields have a probability of a particle that's very low in most space, but the Higgs field has constant, and basically, depending on which way you're going relative to the inertial frame of reference, as I understand it, it requires, you have to take up or emit particles, and that's why it takes energy to accelerate things. He didn't quite explain it, because all these definitions of Higgs field define gravity as a drag, when in fact what gravity is, the force it takes to push something to accelerate it, mass, is, so mass it's not a drag. It basically, you have to put energy to warp the field. And so it's not a drag, because you have inertia. When something's going at a speed, it takes no energy to continue. what is it, a particle in motion tends to stay in motion. You know, one of Newton's laws. So, anyway,
By the way, if you remember the famous Tansey long-term potentiation, has a nephew who is a doctor at Harvard and studies memory and in the medical school. He claims that memory, especially long-term memory, is not stored in the wet brain.
Where's the story?
Quantum. That's Rudy Tansey.
Kind of like a
Rudolph.
cloud.
In the cloud.
In the cloud.
oh, I think we saw him speak.
Rudy.
Maybe, I mean, I thought there is evidence that memory is stored in synapses.
Well, it's in the connection pattern between different synapses, not
Between.
actually in the synapse.
It's in the space.
Yeah. I mean,
Synapse.
well,
Just
Although
a
the
space.
overlap,
The-
I'm beginning to warm up to the overlap.